Hello and welcome to Lesson 2.5. Today we're going to look at solving equations, and specifically we're going to be solving them by either addition or subtraction. So we are going to learn to solve what we call one-step equations using addition or subtraction. As we begin solving equations, it's kind of like keeping a set of scales balanced. The one thing you have to remember is that if you add or subtract something from one side, you must do the same thing to the other side. Otherwise, if you do not, your scales aren't going to be balanced and things will not be equal. So if we look at example 1, it tells us to solve x plus 6 equals 4. So in my head, I immediately start to think when I see the word solve that I have to get the variable by itself. So right now, I'm trying to get x by itself. So in order to do that, I'm going to write this up here. I have x plus 6 equals 4. I have to figure out what's keeping it from being by itself. So in this case, this plus 6 is being attached to that x. So I have to undo the plus 6 to get x by itself. So to undo an addition of 6, I'm going to have to subtract 6. Now if you want to think about it, that equal sign is kind of like the center of your scales. So anything you do to one side of the equal sign, you have to also do it on the other side. So because I subtracted 6 from the left side, I must also subtract 6 from the right side. So now what's going to happen is I have no other like terms on the left, so I'm going to bring my x down. A positive 6 plus a negative 6, those are going to cancel, and that's going to leave me with 4 plus a negative 6, which is negative 2. So when I solve this, I get x equals negative 2. Now I can go ahead and double check this if I want to by plugging that negative 2 in for x right here. So if I go negative 2 plus 6, I should end up with an answer of 4. When I take and I add negative 2 plus 6, I do get an answer of 4, and 4 does equal 4, so that tells me then that I'm on the right track and x really does equal a negative 2. So let's try the same approach for problem B. So for part B, we have b minus 12 equals a negative 49. Again, I'm going to treat that equal sign as kind of like the center of my balance there. And in order to get b by itself, because I have to solve, I have to undo the rest of the stuff. Well, in this case, subtracting 12, to undo that, I'm going to have to add 12 to both sides. So if I add it to the left of the equal sign, I must also go and add it to the right of the equal sign. So now I'm going to go ahead and simplify. So there's nothing to be added or subtracted with my b. Negative 12 plus a positive 12 is going to cancel out. And then I have a negative 49 plus 12. I have two different signs. So I know I'm going to subtract. So I have 49 minus 12 is really going to give me 37. 49 is my bigger number. That has a negative on it, so I know that my answer is a negative 37. So B is equal to a negative 37. Now again, you can always double check by plugging in that negative 37 for B. So negative 37 minus 12 will hopefully equal a negative 49. And negative 37 minus 12 does in fact equal a negative 49. So that tells me that I'm on the right track there. Example 2 says Fred's target heart rate is 130 beats per minute. This is 58 beats per minute more than his resting heart rate. So I have to find his resting heart rate. So what I see is I have 138 beats per minute, or 130, and it says the word is usually indicates equals, And then it says I have 58 beats per minute more than. More than usually indicates that we're adding. So that tells me that I'm going to have 58 plus his resting heart rate. Well, in this case, I'm just going to use R for his resting heart rate. So let's just kind of make sure that we have this set up correctly. So I have 130 beats per minute equals 58 beats per minute more than or plus his resting heart rate. Now we have to find his resting heart rate. So to do that, I'm going to go ahead and I want to get R by itself. If you think about the equal sign as being like the center of those scales, to undo the stuff that's attached to the R, in this case it's 58 plus R. So to undo the 58, this is really a positive 58, so I'm going to undo it by subtracting 58. And if I do it on the right-hand side, I must also do it on the left-hand side. Now I'm going to go ahead and solve. And 130 minus 58 is 72. And my positive and negative 58 are going to cancel. So I'm left with R equals 72. Now I typically like to write my final answer with my variable in the front. So this would really be 72 equal, or R equals 72, and it's beats per minute. And this would be my final answer. For example 3, it says your friend's VCR costs $328 less than her TV. Her VCR cost $179. How much did her TV cost? So $328 less than her TV tells me that I'm going to take the price of her TV and I'm going to subtract $328 from it. Okay, and then I know that the VCR actually cost $179. So I know that the price of my TV minus the $328 is going to give me $179. So now we're going to get T by itself because we have to solve. So again, if I kind of use that equal sign as my balance, I'm going to undo this negative 328 from the T, and I undo negatives by adding 328. When I add 328 to both sides, they're going to cancel off here on the left, and it's going to leave me with T equals, and 178 is going to leave, 179 plus 328 is going to leave me with $507 is what the TV cost. Example 4 says Cora measures her heart rate at 123 beats per minute. This is 55 beats per minute more than her resting heart rate R. Write and solve an equation to find Cora's resting heart rate. So here we know we have 123 beats per minute, and that's 55 beats more than her resting heart rate. So I'm going to say that 123 equals 55 more than means I'm going 55 plus the resting heart rate. To solve for R, I need to get R by itself, which means I'm going to have to undo the 55. The 55 is a positive 55, so I'm going to undo that by subtracting 55 from both sides. And when I subtract 55 from 123, 68 is equal to 55 minus 55 is going to cancel, and that's just going to leave me with R. So R is going to leave me with 68 beats per minute. For example 5, it says the used book costs $17 less than the same book new. The used book costs $9. About how much does the new book cost? So a used book is $17 less than the new book. So I'm going to say B minus 17 because that's $17 less than the new book. And I know that when I find the difference, that the used book is going to be $9. So to find the cost of the new book, I'm going to have to solve for B. I solve for b by undoing the minus 17, and I undo subtraction by adding 17 to both sides. Okay, you do not have to draw the dash lines through the equal sign if you don't want to, but if it helps you, by all means, go ahead and keep doing it. So here I have b, negative 17 plus positive 17 is going to cancel, and 9 plus 17 is going to give me $26. So the new book is $26. And our last example for today says, in 1996, 487 million people across the world spoke English. This was 512 million fewer than the number who spoke Mandarin Chinese. Write and solve an equation to find the number of people n who spoke Mandarin Chinese. So if we know that we can find the total number of people who spoke Mandarin Chinese, we know that that's the people that spoke English was 512 million fewer than that. So I'm going to go n minus 512 million, and that's going to equal our people that spoke only English, which was 487 million. So again, if I want to find the number of people that spoke Mandarin, I have to get n by itself, and I'm going to do that by undoing the subtraction of 512, and I undo subtraction by adding 512 to both sides. When I add 512 to both sides, I'm left with n, or the number of people that spoke Mandarin, and 512 plus 487 is going to give me 999. And because I'm in a story problem, I look at the context. So n is really equal to 999 million people. And that would be my final answer. Please let me know if you have any questions. Otherwise, I will see you guys in class.